So let's summarize what we've talked about when we combine two random variables by adding or subtracting them, and the Pythagorean theorem of statistics. I'm going to skip over this first statement temporarily. So we learned that if we add two random variables, we add their expected values, or their means, which makes total sense. And if we subtract two random variables, we subtract their expected values, or their means. So another thing I could say then is I could say mu of x plus or minus y. So if we add or subtract, this would be mu of x plus or minus mu of y. All right, so we could also write it with mu rather than e of the expected value notation. Now we also learned that when we add or subtract two random variables, we add their variances. We're still a little puzzled about that, but we add their variances. So notice add or subtract here, we're adding their variances. So what I want you to write down here is that variances always add. Okay, we're going to talk about why in just a minute. Which means then if variances always add, then when we do the Pythagorean theorem of statistics, when we take the standard deviation, which is the square root of the variances, that means that is always going to have addition in it as well. So this would be the standard deviation squared of x. Actually, let me put the squared in a different spot. The standard deviation of x squared plus the standard deviation of y squared. And this could also be written sigma of x plus or minus y is equal to the standard deviation of sigma x squared plus sigma y squared. Okay, so that's just another way to write this. Now let's go back and fill in this blank. Variances only add if the two variables are independent. So if the two variables are independent, doing one does not change the probability of the other, then variances add, but only if the two variables are independent. Now standard deviations add even if the variables aren't independent, so we can still add the standard deviations. It's just the variances are based on independent variables. So that means also this Pythagorean theorem of statistics also depends on independent variables. Now you might think, well, what if the variables aren't independent? Could we do something? Yeah, we'll talk about that in the next video. Okay, so let's go to this question. Why do variances always add? So let's say I have a pitcher of lemonade. I fill up this pitcher and I try to get it as close as possible to 32 ounces because that's how much the pitcher holds, and I'm making a recipe of lemonade. Okay, but no matter how hard I try to measure exactly, there's going to be some variability in how much I fill that. So a little bit above 32 or a little bit below 32. So let's say my standard deviation for the amount of lemonade in the pitcher is 1 ounce, and the mean is 32 ounces. Now, then I'm going to pour some lemonade from the pitcher into this glass, and the glass holds 8 ounces. Once again, I try to be really exact with my fill amount, but there's going to be some variability in my fill amount. So let's define the random variable p minus g as the amount left in the pitcher after pouring a glass of lemonade. So I know that the expected value of p minus g would be the expected value of p, 32, minus the expected value of g, which is 8. So my expected value of, or mean, would be 24 ounces. So I would expect the amount left over in the pitcher to center around 24 ounces. But let's think about this. There's variation in the amount of lemonade when the pitcher is filled. There's variation in the amount that is poured out of the pitcher to fill the glass. So does doing both, filling and pouring, increase or decrease the total amount of variation? Well, it increases the total amount of variation because I have done two random processes. And each time I do a random process, it involves variation. So when I do more than one random process, it increases the variation, not decreases. So I am increasing variability every time I do something random. That's the basic idea. Now, these rules that are up here apply to more than one variable or more than two variables. So if I added 3 random variables, I would add their 3 expected values. And I would say if I had 3 different random variables here, whether they're added or subtracted, because those are random processes, I would say standard deviation of x squared plus standard deviation of y squared plus standard deviation of z squared, and I take the square root of the whole thing. So these rules apply to more than one variable. Now in the next video, we'll do a couple of examples of kind of special cases that you need to be aware of.